Hello, welcome to elpt-1325, National Electrical Code 1. This is going to be Lesson 1 for the fall semester 2021. This video lesson is primarily designed for those of you that missed class for whatever reason, including COVID. The school wants us to make this material available for you just in case you do have a problem and you have to access the course material online. So I'm going to have both an online version of this class and the in-person class. So you're going to have options in terms of how you access the material. Today we're going to start the lesson. We're going to start off with some of the introductory material. We're going to be talking about safety. We're going to be talking about the purpose of the National Electric Code. But before I do that, I want to go back and take a look at the material that we have in Blackboard. I added some new material, so I just want to make sure that we can see that, can access it, know where to find stuff. When I did my original introductory video, I had not uploaded all the material into Blackboard, so I've done that now. So here's what Blackboard looks like when you open it up. This is the course Blackboard homepage, and what I have is I have my syllabus over here under syllabus. I've now uploaded that. I'm going to be working on the calendar. I'll have the calendar sometime this week, but you can just expect that we will cover different material and new material every week for the next 16 weeks. And every 5 weeks or so, there's going to be a quiz. So here's where course content is. Over here on the left-hand side, you click on course content, and you're going to find that there are several things here. The first is the introductory video. You're also going to find this lesson, but I'm doing that lesson right now, so obviously I don't have it to upload yet, but I'll get that by the end of the day. And you'll also find a copy of the 2017 National Electric Code in PDF version. This is free for you to use. Go ahead and download that. I don't think they'd like me to give that to you, but the National Electric Code is developed by a government agency, so technically it should be free, although they do need to make money somehow. I've already uploaded the assignment for the first week, and let's go ahead and find that. Now, how I get into it is I go into the Grade Center, and when you get into the Grade Center, you're going to find some information here. I've only put one assessment into the Grade Center, and it's right here, this week 1 notes. This is where you're going to submit your notes. And so you're going to go over here to the right-hand side, and you're going to click that, and it's going to bring a drop-down menu, and somewhere in that is going to be a place where you can upload the assignment materials. So that's how you get to that. I have material under Start here. I have my syllabus. You've seen the first announcement. There's course content, and there's a assignment in the Grade Center. So let's go ahead and get started with the actual material in Lesson 1. And this is just going to be a kind of an introduction to the National Electric Code. The National Electric Code is way too complicated to even cover in one semester. In the first 4 chapters, there are something like 340 or so pages. That's a lot of material, particularly considering how dense it is. So the very first question I always like to ask is, what is a National Electric Code? And this definition here in red is what the National Electric Code is: the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. And that is the definition. That's the description that is used. I didn't create that myself. So you can read this yourself. I do expect you to write all this stuff down. Take notes on this. I do expect you to write this by hand. You can type it in. I understand that typing is not as good as writing by hand. Something about writing something down by hand puts it in your brain better than just typing it out. It's actually a better form of learning. So I do recommend that, although I'm not going to say you cannot submit a Word document or a PDF document or something like that. You can go ahead and create those as well if you like, but I do prefer handwriting. One of the things I know is you did it yourself if you wrote it by hand. One of the things I want to mention about the National Electric Code is that you really do have to be trained to use it. An untrained person is going to want to cut corners. They're going to want to look at the National Electric Code and see that there are a lot of details. There's a lot of complexity there. They're going to try to cut corners. They're not going to understand how to do some of the requirements in the National Electric Code or why you're doing some of those requirements. So this class is designed to teach you some of the details about why the National Electric Code is important and why you need to adhere to it. The National Electric Code is a law, by the way. It's a law that has been approved by states. It's developed nationally but approved individually by states. And here are the states and the different versions of the National Electric Code that they have implemented. One of the things you're going to notice is that some states are further behind other states. Not every state uses the newest version of the National Electric Code. So there's a new version of the National Electric Code out right now. It's the 2020 version of the National Electric Code. As far as I know, no state has approved the 2020 version of the National Electric Code yet, although they should be doing so in the next couple of years. So who develops a National Electric Code? It's developed by the National Fire Protection Association. Let me show you their website. So here's the home page of the National Fire Protection Association. And they have a copy of the National Electric Code, which is NFPA 70. That is the standard that they're referring to. They have a whole bunch of different standards, by the way. So you can find the list of their standards over here under Codes and Standards. And there is a way to access the National Electric Code for free yourself, but they really want you to subscribe and join the National Fire Protection Association. I think there is a fee associated with that. So the National Electric Code is a set of minimum standards. We'll talk in a little bit about how many years of apprenticeship you need to go through. That's set by law. A little bit later I will mention that it takes about 8,000 hours of studying and working under a licensed journeyman electrician in order for you to become a licensed electrician. You also have to pass the licensing exam, which is really, really hard. So there are a couple of standards here that you have to do. Now, one of the things about the National Electric Code is that you're expected to follow every electrical standard. I don't want to infer that there are any shortcuts that you can follow at all. I expect you to not only follow the standards in the National Electric Code, but to exceed those standards whenever you can and whenever is necessary. Remember, these are minimum standards. If you feel like something needs to be a little bit more robust, then that's what you should do. So why have an electrical code? It's all about safety. That is the key to the National Electric Code, and this is why you don't want to cut corners. This is why you want to exceed the standards when you can. It's about promoting safety, and it's about minimizing risk. So one of the things that most people think about when they think about electricity is the risk of electrical shock, and that certainly is a risk. But the biggest risk is the heat that current generates. Heat creates fires. We all know that fires are dangerous. You can burn yourself, you can burn your house down, you can burn your building down. So one of the things the National Electric Code tries to do is minimize the amount of heat that's generated in an electrical installation. And that's one of the things they mean by safe installation, how to minimize heat. And this is not just the conductors, it's the connections, it's eliminating the risk of short circuits, it's eliminating things like arcs or ground faults. There are a lot of elements in electrical safety that you need to pay attention to. So the National Fire Protection Association is not the only organization that sets safety standards. You probably already know about the Occupational Safety and Health Administration, OSHA. Now, on this particular slide, I don't really care that you write all of these things down. You should probably know what some of these acronyms are, the abbreviations, OSHA, NFPA, ANSI, IEEE, and the IEC. You should know what those stand for. But these individual sub-items right here specifically refer to arc fault protection. Although, of course, the National Electric Code itself deals with all kinds of electrical safety, but some of these other specific ones deal with arc faults. And so you've got some specific guidelines here that deal with that. These are not every organization that deals with electrical safety. We also have organizations such as NEMA, the National Electrical Manufacturers Association, and Underwriters Laboratory. They're primarily concerned with adhering to the standards in the National Electric Code and making their equipment safe. So the National Electrical Manufacturers Association and Underwriters Laboratory certify that their equipment is safe. So they have to build their equipment to follow the standards, to meet and exceed those standards. And when something is listed, that shows an inspector that that equipment is safe to use in that particular installation. So the National Electric Code was developed to establish uniform levels of safety. And it's designed for North America, although I think some of the other nations, they either use versions of the National Electric Code or they create their own, but a lot of these are based on what's in the National Electric Code. Let's talk a little bit about electrical injury. Most electrical injuries occur in the workplace. Electrical injuries are the fourth largest cause of workplace-related death. There's about 300 workplace-related electrical deaths every year, and there's about 30,000 shock incidents every year. 20% of all electrical injuries occur in children. Children they don't know what's dangerous and what's not. So it's up to the installers and the people that have responsibility to minimize the risk of electrical shock for people that they don't really know any better. They don't know how dangerous something they can't see can be. So one of the worst consequences of electrical shock is that you die, cardiac arrest, fibrillation, but minor shocks are much more common. And these can not only be very, very painful, but they can also cause significant injuries, burns. You can subject yourself to an electrical shock and fall, break a leg, break an arm. I have a story that I talk about here. I was in the Navy many years ago, and I was an electrician in the Navy. I was an electrician on a nuclear submarine, and one of my stories is about being shocked by working in an electrical panel. And one of the things that happened to me is When I got shocked, it caused my muscles to spasm, and I basically got knocked back about 6 or 8 feet. It was just basically like I was inadvertently or uncontrollably jumped backwards. Now, the bad thing about that is that I was on a ladder, and I was about 3 or 4 feet up in the air. So that could have been very, very dangerous for me. It caused me to be stunned. I was stunned. I laid there for maybe a minute or 2 minutes. So the muscle spasms, that's a serious thing that electrical shock causes. So this table shows some of the different levels of electrical shock. And there are basically 4 levels of electrical shock, although the most serious level is broken down into subcategories of electrical shock. And this is an electrical shock chart that is for alternating current voltage. And there would be a different one for DC, although I don't think I've ever seen one for DC. AC is more common in the household, in industry, and so that's the type of voltage that you're going to run across more often. And alternating current is more dangerous. It's considered to be about twice as dangerous as DC voltage. So you can read through this chart, and there's 2 things that this chart details. One is the amount of current. I is the symbol for current down here on the bottom. And so the severity of electrical shock depends on the amount of current that is flowing through your body. The second thing is the length of time that electricity flows through your body. So this is a chart of current versus time, where the longer the electrical current flows through your body, the more dangerous that current is. So reading off this chart, this point right here is considered to be the point where electrical current is deadly. And that point, if you read down here, is 100 milliamps of current flowing through your body for half a second. And the way this works is if you have 100 milliamps of current flowing through your body for half a second, you have about a 50% chance of going into fibrillation and dying, which basically means your heart stops. What your heart really does is it tries to vibrate or oscillate, tries to pump about 60 times a second, and obviously it can't do that. So it stops your heart. While you've got the electricity flowing through your body, it tries to pump at 60 cycles per second, but after it stops, your heart just stops. So you have some fairly low currents, and as long as these low currents are for short durations, not real dangerous. And another story that I always like to talk about when I was in the Navy, I used to deliberately touch an electrical circuit to find out if it was energized. That was kind of stupid. I shouldn't have done that. I don't really recommend that, but it was just a shortcut. We don't want to take shortcuts when it involves electrical safety. So here's a list of the things that determine the severity of electrical shock. And the severity of an electrical shock is determined basically by 3 things. Now, this is besides your own health. That's not determined by the amount of electrical shock. That's determined by your physical conditioning and whether or not you've been sweating or if you're wet or things like that. Those are things that are a little bit out of control of the electrical industry. But the 3 things that determine the severity of electrical shock are the amount of the current, the duration of the current flow, the time, and the path. Obviously, it's more dangerous if current flows through something like your heart or your brain or your liver or your spleen. Really, you don't want current to flow through any organ of your body. One of the things that electricity will do is it'll burn stuff, and you'll cook from the inside out. And I'm here to tell you that is not a good thing. So one of the ways that you protect yourself against electrical shock is you wear your personal protection equipment. And there are a variety of different elements of personal protective equipment, including insulating gloves, insulated boots, rubber mats, and insulated tools. Sometimes we count a little bit too much on our electrical circuit protection. But these devices are designed to protect the equipment, to limit current to a level low enough so that it doesn't damage the equipment. And so you consider a piece of electrical equipment that can handle, say, 10 amps. So you're going to have a fuse that blows at around 10 amps. But if you allow those 10 amps to flow through your body, which is a level where the fuse does not blow, you're going to be dead. So we do have electrical circuit protection devices that are called ground fault circuit interrupters. Ground fault circuit interrupters are devices that are designed to protect people, because by measuring ground fault current, they can measure very small amounts of current in the milliamp range and can interrupt the circuit on those very, very small levels, and that will protect you. So ground fault circuit interrupters are required in households, in homes, in places like bathrooms and kitchens, anywhere where there's some water, anywhere where there's the potential that a ground fault can occur. AFCI stands for arc fault circuit interruption, and that's a fairly new standard. They've learned that arc faults are one of the major causes of electrical fires, and so they put in place electrical standards that limit arc faults. An arc fault circuit interrupter, we will talk about this in more detail later. It's really an electronic device. It's designed to look at the occurrences of spikes in electricity that occur several times over a short period of time. So it looks at like little pulses of electricity, and it senses that, and when it senses several of these pulses of current, which is what arcs do, they produce pulses of much higher current than the normal circuit. When it senses these periods of several sharp spikes in the amount of current, it'll interrupt the circuit and shut it down. Arc faults are generally caused by poor connections. It can also be caused by corrosion and worn out wires and things like that. So the best protection is humans, like yourself, being aware of safety, constantly demonstrating safety awareness, being aware of your surroundings, being aware of any hazards in your environment, avoiding those hazards, and trying to eliminate those hazards in your workplace. That's on you. If you see a hazard, do your best to fix it. Don't just pass the buck. So I also want to make sure that you guys understand that this class is really about protecting yourself and your coworkers. And that's why we don't want to just meet minimum standards. We want to pay attention to the intention of the National Electric Code, which is protection and safety. And take that seriously. So here's a few details about what the National Electric Code does and does not do. There is some confusion out there in the general public about what the National Electric Code does and does not do. It's basically a bunch of standards. But what it doesn't deal with is it doesn't deal with efficiency or convenience, energy management, power quality. Those are things that engineers might be concerned with, but those are not things that involve safety. So you might think this electrical installation is poorly designed. It's hard to get in there to service something. It's hard to get in to expand something. Well, that installation can adhere to the National Electric Code and still have some poor quality. Obviously, you'd like to have all your electrical installations be convenient, be efficient, be quality, but the National Electric Code deals mostly with safety. So the National Electric Code has chapters, articles, parts, sections, subsections, and sub-subsections. I want to look at that.
Let's take a look here. National Electric Code 2017. So I always like you to open up the National Electric Code in Acrobat Reader because you can get to the chapters over here on the left and you can click on those and it'll take you right to them. This is kind of convenient. So if you have a tablet or even a laptop or something like that, you can take this out in the field and you can get right to the relevant section of the National Electric Code as long as you are opening that National Electric Code in something like Adobe Acrobat. These days, having a paper version of it is just not very efficient at all. So Article 90 is the introduction. Doesn't deal with the details of electrical installations or anything like that. National Electric Code really starts with Chapter 1. And so in Chapter 1, you have articles. And all of the articles in Chapter 1 start off with a 1. So you have Article 100. And under Article 100, right off the bat, we have parts. So here's Article 100, Part 1. And as you go through this, you will see how they organize the National Electric Code. Well, this is not really a good example right in here because the first part of Chapter 1, Article 100, is definitions. And so all they do in Article 100 is define these various terms. We will be doing that ourselves. We're going to be looking at these, but not right now. So let's go into Chapter 2. Let's take a look at Article 200. Article 200 involves wiring and protection. And so we have sections here, 200.6, 200.7. These are examples of sections. So we have more articles. All the articles in Chapter 2 start with a 2. So here's Article 210, 210.5, and then they have these subsections that are labeled A, B, C. And then we have subsections. So you can have Article 210, Section 5, subsection C, 1A, for example. So you go down into the details of the specifications in the National Electric Code, and sometimes these layers go pretty deep. So 210.5.C.1a involves the means of identification, shall be permitted to be by separate color coding, gets pretty specific as well. That's one of the reasons I wanted to point this out. Okay, so that's the layout and the organization of the National Electric Code. When you refer to the code, you're really talking about the specific code, the section and subsection of an article, not just the article itself. Article 210, for example, has way too much stuff in it to refer to Article 210 by itself. You got to detail the subsection and subsection. So I always want to talk about how you would become an electrician. These are kind of the steps. We're not going to hire a person to be an electrician without at least a high school diploma. Obviously, all you guys have high school diplomas, or you wouldn't be in this class. But you also have to complete an electrician training program. That's what you're in this class for. You have to apply for your apprenticeship. You have to complete a 4 or 5 year apprenticeship under a journeyman electrician, and you have to pass the license certification exam. This is a multi-year, difficult process. The certification exam is not easy. And obviously working for a boss that controls your future is not a fun thing to do either. And you have to work under that boss for 4 or 5 years. Hopefully you'll be working for someone that's kind of a nice guy that wants to help you learn, give you some responsibility, give you some tasks where you're actually learning how to do stuff instead of just being a gopher. So here's where you can find some apprenticeships. One of the best places to find these apprenticeships is these independent electrical contractors. There are a number of these throughout the Houston area, dozens and dozens. They're everywhere. So that's how you get your foot in the door. You get hired on as a helper. You get hired on as a helper. And then through your hard work and your dedication, you get noticed, you get recognized, and you get promoted. You move up till you start working underneath the journeyman electrician. They learn to trust you. And then you get those 4 or 5 years of experience under your belt. You study the National Electric Code. You take the apprenticeship exam. And you pass it. Maybe not on your first try. So these are some of the requirements in Texas. So to become a residential wireman, 4,000 hours of supervised on-the-job training. That's about 2 years. A wireman is a little bit different than an electrician. You're going to be working on power lines, overhead power wires. This is the kind of job that you might do for companies like CenterPoint Energy, deal with wiring. Journeyman electrician, they work on both residential and industrial electrical systems. These are the kind of electricians that you might find with some of these local electrical companies. And of course, to be a master electrician, the standards are even higher. 12,000 hours is about 6 years of experience under a master electrician. So shoot for becoming a journeyman first. It's about 4 years of supervised on-the-job experience, maybe 5. And I'm going to stop right there. That is it for the lesson for today. And all I expect you to do for this lesson is to take notes, write those notes down, and submit those notes for credit. Simple, right? See you next week.